One new thing to here might be this last bit of this section here is talking about even and odd functions. Even and odd functions. When you look at this, it might not make too much sense right away, or it might not be obvious what this means. Even and odd is a couple different types of symmetry that a function might have. If you have a function where this is true, where the function value for negative x is the same as the function value for positive x. If you pick any x value here, 3, and this negative 3, if those have the same function values, in other words, if they're both 7 or whatever, that's an even function. So an even function is going to have that symmetry that it's the same on either side. So if you drew something like that, just ignoring the fact that it's not perfect because I just drew it, that's an even function because anywhere you go on one side or the other has the same function value. I should probably use this instead because this is going to make it a little more obvious. Cosine is an even function because anywhere you go on either side here, okay, if you look at any one of those points, you can see the coordinates there. The function value is 0.36 for positive 1.2 and for negative 1.2. Anywhere you go there, it has the same function value. All right? That's an even function. And so this one is even. An odd function has the property that the function value for negative x is the opposite of the function value for x. Okay? This one says they are the same. Function values are the same. This even is function values are the same. Even is they're the same for positive and negative x. Here they are, when a function is odd, it's that the function value is the opposite. F of x equals negative, f of negative x equals negative f of x. This is opposites here. These are opposites. So if you drew that, if you had some piece up here, like that, pick a point here, 2 is, let's say it's 3. If this is going to be odd, then the value at negative 2 has to be negative 3. Okay, it has to be down here somewhere. So if I was going to draw this so it's odd, it's going to look something like this. Okay? Okay, if it's even, they have the same value. 3 is that. Negative 3 is the same thing. Odd is if 2 is positive 3, negative 2 is negative 3. Or vice versa there. Okay, again, let's look at something a little more dynamic than my drawings. Whoops, not that. Can you think of a function here that I can replace that with? That's an odd function? What do you think? Come on. Not that hard. What could I replace this with here? Can we refocus here up on the front for a minute or two more? Give me a function that's odd here that I can put in. Cosine's even. What about another trig function? Tangent. Tangent is odd, right? Because if I go on either side here, right? Let's go where you can see it. Oops. About there. 0.9 has a value of 1.26. Negative 0.9 has a value of negative 1.26. Even if you go right to there, right? 2.2 has a value of negative 1.37. Negative 2.2 has positive, right? They're opposites. The function value are opposites for opposite x values. Whereas an even function has, oops, I have to go back a few here. An even function has the same values, right? For opposite x values, same function value. Whether it's positive or negative, whether the function value itself is positive or negative doesn't matter. It's the fact that they are the same. All right? If you go back to that page you had, there were 3 different functions there. One of them we wrote, hopefully you drew a picture of this already. Something like that. Cosine is even, right? You could probably draw on there something similar to what I drew up here if you haven't already drawn something like this to make some notes for yourself. 1 over x, do you know what 1 over x looks like without using the calculator or the graphing software up here. It kind of just, yeah, it goes something like that, and then there's a negative part over here. This is odd. And, oh, this one right here. Do you know what x cubed plus 2 looks like? First of all, do you know what x cubed looks like? X cubed actually looks like, well, the right side of it looks a little bit like x squared does, but the other side of it is negative instead of positive. Okay, things with odd powers there look like that. Now, that function itself, without the plus 2, what would this be? It would be odd, right? The thing is, if I shift it up 2 here now, that's what that does, right? If I shift this up, whoops, I don't want the black part. Just that, no, go back. Can't quite do it. Well, we'll lose the arrow. That's okay. If I shift it up 2, okay, there's shifting it up 2. Lost my arrow. Now that is the graph of this with the plus 2. Is it odd still? No, it's not, right? Because let's use the technology instead. A little more effective then. If you put in x cubed plus 2 here instead of that cosine, x cubed power of 3 plus 2. There's x cubed plus 2. The scale's a bit weird. It's still on the trig scale there, but that's okay. If I find some points here, there's a couple points, right? Negative 0.8 and positive 0.8. Those are not, these are opposite x values, but these aren't the same, and they're not opposites, right? They're not the same, they're not opposites, it's neither one. It isn't necessarily true that a function is even or odd. It's not like numbers where it's even or it's odd. This one is neither one. Okay, because of those two values. There isn't that symmetry there. You can't reflect this function and have the values the same, right? The function values aren't the same if you reflect that thing. It doesn't reflect onto itself sideways. And it doesn't reflect kind of that turn symmetry, right? Odd functions almost have a rotational symmetry. Like if you rotated this around halfway, it would end up on itself. Okay, if you want to think about it as a symmetry like that. This one is neither one. You should probably put a note down for why that is true. Okay, why it is neither one. If you just draw any kind of a random scribble, chances are it's going to end up being, what's that? From what we can see here. It's neither one, right? Because you can certainly pick a point there that is different, right? That point is different than whatever this side is, right? They're not the same and they're not opposites. So that's even an odd function, just so you know that terminology. Take a minute now to start having a look at piecewise functions. The next thing, if you haven't done that, I'm going to stop this.